We wanted to welcome Kathy Lueders, who is going to talk to us about commercial crew status, something that we're all very interested in, and hopefully will be coming to fruition pretty quick. So, Kathy, thank you for coming.
Oh, thanks for having me. So, let me get started. First of all, we always start with the picture of the crew. That's why we're here. We actually just started a campaign where we have banners of our crew members for each of the missions, and so been able to send them, are currently sending them, and as the vehicles are starting to go through their final progress and being shipped out, making sure that the team members that worked on that particular vehicle, that particular mission, are signing where the crew members, the faces of the crew members are, and making sure that we're all signing up to the fact that we're working to fly our crews as safely as reliably as we can. Next slide. You guys know who you are. Next slide. Yeah, some days, like Ruth says. We're going to go through overall kind of the program progress, and then getting into each of the missions and ending up with still working through supporting our space activities. Next slide. This is a slide where we kind of talk through what our current kind of official dates are. The Boeing guys, honestly, they're on the range right now for the 17th, where I'll get into this a little bit as we're working our OFT mission preparations, but as you know, it's a very complicated dance as we're getting ready to go fly, along with finding the right day to fly to station. And then we're also working, this is a busy first quarter for ULA, and so there's a lot of discussions about how does this readiness for this mission then fit into the rest of the manifest, but we're working through that. And then I'll talk about readiness for Demo 2, crewed flight test, but really this is a very, as you guys know, we're heading into this major period of final big integrated tests, and I'll kind of walk through all those big activities that we're burning down, along with tons of certification work going on for the team. We tend to not say it's just paper, because it's not just paper. It's all the key things that are showing that the design is qualified and that we have the vehicles at the right risk level for us to be able to fly on them. Next slide.
Some things never change.
No, I know. No, I don't. Tell me, it's still really hard. That last bit, as you can see, getting these last few check marks here are super hard, and so I'm going to talk through those. But these last few check marks are really hard. I once made the mistake of saying we're on the 95-yard line, and that red zone's really bad, and all the football guys were like, "Kathy, stop using sports analogies." I'm on the 5-yard line, and it's really hard. I'm on the 1-yard line, and it's really hard. So we'll keep going. Next slide. So let me talk first about Boeing. Next slide. So what's really nice is in this package, we don't have any artist rendering except for the very beginning where you saw the vehicle docking. So right now we have our pad abort, the pad abort test vehicle is up on the stand. We're doing, and it's at Wismar, vehicles stacked up on the stand, getting ready to go. It's got the point, part of this is to do that checkout of that Mode 1A abort. And so it's got the spacecraft CM and SM, and then it's got a LVA, launch vehicle adapter, we had to do updated abort vent doors, and so checking out that. So we right now are on the range out at Wismar for next Monday morning to do this checkout. Huge steps for us, right? So obviously, it's going to be important for us to understand how does the separation systems work for the CM and SM, checking out the chutes, making sure that the predictions for are lined up, right, for us. So there's the risk for this test for OFT. OFT does not have the abort system on it because it's an uncrewed mission. but obviously the way the system's separated and everything else will reflect on our OFT progress. So it's critical for us to get this test going, and that we understand it prior to us doing rollout of the spacecraft. Next slide. So orbital flight test. So we got paddleboard on next Monday, and we're looking at doing spacecraft handover to ULA the following week. So also very busy time. Obviously, the Boeing guys right now are going through final CM to SM checkouts, so final closeouts, and we're starting over the weekend to begin our fueling operation. So that spacecraft getting ready to go and be handed over to ULA. The boosters here, obviously working through final reviews with the ULA folks, getting ready for the test coming up in December. You know, we've worked through all our big integrated testing on it. You know, so you go through that subsystem level, getting through structural test article testing, all of our environmental testing, went through our 5 parachute system quals required for working through before OFT, and then all the integrated tests working through. We actually did our crew interface testing over the weekend and did our final crew walk down yesterday in the C3PF. So, I mean, you think, next slide. And then was there also, if you, I think did you guys have a tour? Have you had your tour yet?
We did not go, we did not go to.
Oh, you didn't go, okay. So you would have been able to, with the tour, OFT finished out, and then they also have the crewed flight test vehicle, which is a spacecraft 2, is now currently mated, and they're in the process of working through docking system installation. They're working all the ecosystem and all the outfitting on the outside and working through the testing. So they've been doing, you can see right there, they've been doing crew training, and interface testing, and working through, as you know, it takes a lot of work kind of doing the final spacecraft installation. The booster is also been completed, and right now the Boeing guys are looking at having all the outfitting, final preps for the vehicle, and that being done by the end of the first quarter in 2020. So if you guys would have gone over there, it would have been really cool, because you would have seen one spacecraft really going through final testing, getting ready to go roll out the door, and getting ready to be going in for fueling, and another spacecraft mated and getting into the final outfitting. So just a tremendous amount of progress, you know, working through this. Next slide. Obviously, you're not ready until you're ready from an operational perspective, and we've been doing a lot of planning and training with the DET, with our rescue forces, so you can kind of see, you know, the work that's been done up there. The team's getting ready. Been doing a lot of joint simulations, getting ready for the wet dress rehearsal on the OFT mission coming up. But kind of how do you work with a joint, not just a Boeing ULA team, but a Boeing ULA NASA team, and how do you work through that, has been very critical. Also doing joint simulations with the ISS. So, and then, you know, we've had to work through what is ground, the crew recovery. So you can see pictures of where they've done different planned training for recovering the vehicle. Go ahead, Ruth.
Remind me, is this one at the baseline to land? On land?
On land, right.
Okay,
Working
so
at different ranges.
Okay.
Right. Primary for the OFT mission right now it's Wismar and Wilcox, right? But we have different ranges that they can land at depending on reentry days.
Kathy, is this still going to be a long duration flight for the OFT?
OFT, short duration, CFT, I think you're thinking about CFT. Right now, we'd had CFT be a longer duration.
Do you know how long?
Not yet. We're kind of waiting to see when the rest of the vehicles are kind of stacking up and working that, but the goal would be to, be able to use it, we can use it up to the 6 months. Right. So, tremendous amount of work. I mean, I can't, I always, you have 4 slides and you feel like it doesn't, really encapsulate all the different areas, but tremendous amount of work by the Boeing NASA team working all the different aspects. And like I said at the beginning, my favorite part of this is it's real pictures. So you're seeing real hardware, real capability there.
Yeah, you just note the bottom picture down there that those of us that were at the IAC really got to go sit in the van, they get it on display out there.
Oh, cool.
It's kind of cool.
Yeah. So we'll move over to SpaceX. Getting ready to actually, so next week we're getting ready to take our in-flight abort vehicle and put it on the stand and do our static fires. So I think folks know that we brought Demo 1 vehicle back. It was very painful, but we brought Demo 1 vehicle back, did processing. We're actually getting ready to do our in-flight abort test on the SpaceX side and went into static fire, and then we had an anomaly. And the team, honestly, both the SpaceX and the NASA team has been working through the anomaly investigation, working through propulsion changes. We're in the process right now of finishing up all of our material testing, integrated testing and everything to clear the new propulsion changes that needed to be changed for the vehicle. As Tommy knows, we have these gifts. This was a big gift for us. I actually think that the fact that we had static fire, that vehicle was on the ground, high-speed cameras, all the instrumentation, we were able to pinpoint where we had issues and be able to fix them, and then be able to go and lay out the testing plans that we need to have in place to make sure that we feel like we're comfortable with this vehicle going forward. So, static fire next week. We have a plan then for we make it through static fire. Then the goal is to have in-flight abort tests early December timeframe. And but obviously we got to get through static fire first, and then the SpaceX folks will go get on the range in early December.
Kathy, can you share what the issue was with the design, manufacturing, installation?
No, it was design. It was design. I think there's like 3 things that we learned. One is when you're for both providers, they're using new pressure abort systems, and so they're not using what we did for Orion or for Apollo, where they have a solid motor that's using it. So the nice thing is these are very integrated systems, so you're able to use the prop that you don't use for aborts, you're able to use it as capability for your vehicle. So it's a nice mass trade for your vehicles, and to kind of give your vehicles opportunity if it's more capability, if it's from a prop perspective, if you're not using that capability from an abort scenario perspective. But what it did was the SpaceX folks, because of their integrated system, they hadn't realized that when you're going from your low flow to your high flow systems, there was this potential that you would have this pressure wave. And with the pressure wave, and we learned that there was, at these high pressures, with exposed titanium, there was a compatibility issue that we, even in the NASA community, hadn't realized with NTO. So we learned something. We all learned something, that when you have this high pressure wave come down, and we had broken a valve and exposed titanium, then it caused the system. This was compatibility that we all had looked at, but didn't realize that our compatibility matrices had all assumed a system operating with these lower pressures. So we've actually, over the summer, had to build a compatibility matrix for the pressures that the system will be operating at. The other big changes we did was we put a burst disk in to be able to isolate the low flow from the high flow portions of the system, so that what had caused this pressure wave, there was also had been some propellant migration up into the helium system. Check valves check somewhat, but you also can have leakage with check valves, and so it ended up that you had leakage and you had a slug of fluid in the system that went through the system, hit the valve, caused the damage, and then also we had this reaction, right? So there was a bunch of things there. We knew that there was migration from the check valve. We just didn't understand what the migration meant with the high pressure system, with this exposed titanium, and we learned something about the system. So the SpaceX guys and our NASA team, we've been working together on how do you address those three things, right? And making sure that the system that we're using for the static fire next week addresses those three concern areas.
That's why we test.
Well, like I said, it really, there's a lot of things that people said, hey, in our experience space, we know we have check valves and we know you get a certain amount of prop that leaks up, but nobody, we're like, yeah, that's in our systems a lot of times, and you got to be careful about, when that thing about the kind of feeling like you're really understanding the situation. And on our side, when we look back, we're like, okay, well, we didn't understand these three things together could have created this really bad day. And so it would have been a bad thing for us to have found out on orbit, right? So I think now we've gone through it. I think we've been doing a bunch of slug testing. We've been doing a bunch of testing in this particular environment and making sure that the systems that are in place are robust for that same type of failure. We also have now, basically built a oxygen compatibility matrix with NTO and titanium, kind of expanded what has been out there. There'll be a Janus paper on this for sure, and so I think, but this is also honestly for us, I think for the year going into crewed flight, having something like that happen is a big wake-up call for the team, that they have to be diligent and careful about this. We lost a vehicle very quickly. That was a very dear vehicle for us. We were on a high coming off Demo 1, and to lose that vehicle was going in a museum somewhere. And so it made the team, and I'm really proud of the way the team over the summer has carefully kind of gone through, worked through the anomaly investigation, worked through the changes in the system. We learned something with the Boeing vehicle the year before and had the same kind of thing working through. So both of these types of systems, we're learning through this, and our integrated testing really fleshed that out for us. Okay, next slide. So it kind of goes from static fire, but obviously the whole point of all this work is to make sure that we understand, and test the system that's going to go fly our crew. So the nice thing is that the SpaceX folks had a bunch of vehicles in flow. So even though we lost Demo 1, if you think about it, we lost our in-flight abort vehicle last April. They were able to pull up what was going to be our Demo 2 vehicle, outfit it, make the changes to the vehicle, the upgrades to the vehicle, and get it ready with a 6-month slip, really, that ended up with. So pretty phenomenal turnaround. So we are now headed into the static fire for this vehicle, and like I already talked about, the goal is to get through static fire, and then go through, after they do static fire, they'll have to change out those burst discs, go work through and then get it ready for the fueling and everything else, and then get it ready for tests. We're shooting for early December for the tests, but they'll go on the range after we get through static fire, make sure the vehicle's okay. I think right now we're planning on static fire mid next week.
What's magic about 88 flight? Is that
So
dynamic pressure?
they just looked at, you know, when they wanted to make sure that we had a fairly stressing case, but not super stressing case you wanted the test to be working through. So there was some debate about 88 versus 100, and I think it was like 106, and the team kind of went through the profile. Really, you just want to make sure that we've got a test that's exercising that one mode, and that we feel like is at a place where we're getting a real sense of the overall vehicle integration at that level. But honestly, Jim, you can imagine how many hours we had about the whole profile, and you know which part of the profile we wanted to enact. It's at the more stressing case of the profile, and but it's not the most. I mean, we could have gone more, but we also really want that vehicle back, and we want to you know, we want to make sure that we get the data. So there was a big trade between them.
I assume you can extrapolate data from that point to the worst case.
Yes. And really, we're doing it with Monte Carlos, right? So it's just to make sure that we got all the instrumentation. This vehicle's.
So if it behaves properly
Right.
at that point, you'll have enough data to understand what might happen at the next view.
Right. Well, at least, you know, and this is at least to say that it's matching up with our predictions, because it's the whole thing, you know, there'll be some discussion, we'll have to go look at it, right? But the whole
Make sure
goal
you
is
know
to
what
go
you're
say that's one case, right? It's the thing we always struggle with the abort test is it's one test, right? So purists would probably go, you want 3 tests, but you know the problem is that there's a trade here. So really, it's about what do we predict at that, and were we close enough in our predictions to feel like the model's telling us the right behaviors, right? The other thing is to just make sure that the whole system, it's a validation test that the whole system's kind of operating the way it should.
Okay.
The other thing that the in-flight abort test is doing for us is, you know, this is a different operation, and the thing that we've learned, and we learned through Demo 1, is you have to be careful about when you're taking a launch team that does ELV missions, and then you're doing a crew mission. It's the things that you do different that you have to be really careful about, right? And so our crew timeline is a difference. And so we've done a lot of dry runs with the team, taking the crew out, making sure, doing the walk up, doing the timing, going in, you know, capsule working. We did some before Demo 1, but we really want to make sure with the joint launch team and with the joint teams that we're kind of walking through the whole crew timeline and making sure that we've simulated it and working through that, and with the launch team too. So we're doing it for, you know, the static fire. We're actually doing a dry run too for the static fire and kind of working through the timelines, and helping our team for the F9 static fire, and then also for the in-flight abort test to make sure that the support teams, we've got them trained and thinking about how we're going to do that heading into the mission.
Kathy, has there been any lessons from the Orion SN abort tests that were passed on to the team for their SN abort tests?
I don't, you know what, Lynn, I don't think we really talked that. So it might be a good thing to just go. I don't think, you know, that wasn't really with the launch vehicle. So
Sure,
where, you know, it's not, it's a nice thing about with the SpaceX guys are actually bringing in they're treating it like it's a flight. So they're bringing in the whole launch vehicle team to go run through, like we're gonna have all our console support, everything set up to kind of treat this like a flight. So, A2 wasn't like that, but it's a good thing for us to go ask the question. Demo 2. So, spacecraft in final outfitting, out at McGregor right now. They're looking to working through the different. We've actually gone through avionics and the system checkouts, and working through right now the final pieces, getting all the pods, the Draco pods, finished up and installed, and that's shooting for the end of the November time frame, and then having the spacecraft ship out in December. They're kind of waiting to see, with the flight abort tests and everything else and they also have a busy manifest in the December time frame, so they're looking at when's the right time to have the vehicle be shipped out. The first stage is already done and the stage has been completed. We're going through our pre-stage test checkouts on the second stage. You can see we've been working through our spacesuit production for Doug and Bob, and one of the big activities, and I'll talk about it and when we get on the next slide, but we've been really working through how do we go through all of our suited crew training, getting all our displays and the crew capabilities up and running. Folks have heard a lot about chutes. We've been working through different chute testing. SpaceX guys did 12 chute tests in a week as we've been perfecting the Mark III designs. But we're continuing to work with them on kind of what that schedule is and finalizing that, and then we'll be looking at trading and understanding final test results as we head into the December time frame. Next slide. So same type of thing, a lot of work working through. We'd actually added some additional integrated cabin review demonstrations, milestones to the contract to get further finalization. You can see on the top there, they were working pad rescue capabilities, working through, going out all the nominal and contingency crew exercises out of the pad. Same type of thing. We're doing a ton of joint simulations and M&T simulations. There's a real choreography that has to happen. Demo 1 was a good practice session for us to be able to work through. I mean, we implemented our DMMT, how you do handovers, that, the L-2 time frame, how that team works through that, how they work it with the station side. So it was working with the commercial provider and kind of working through how you work through those pieces and move from agency review into final program reviews into your near real-time ops was a huge practice.
So the Go Searcher, that's their recovery.
So yes, we're working through. We've had there's a recovery boat set up, and so there's a Go Searcher, and there's actually two boats. There's the boat that they have that actually goes and retrieves the crew, and then has the capabilities to be able to have the docks and everybody else on the boat to be able to go do that. So the team all came out. They've done water runs with the joint teams, the rescue folks.
How are they getting the crew out?
They actually they lift the whole vehicle onto the boat. Okay. And then they have it where they have it set up where they can actually, at the level of the hatch opening, they have the scaffolding and everything else where they bring them across so that they're trying to keep their equilibrium as consistent as possible and then have the rooms at that level too. So we've done it. We've done the helicopter rescue exercises, and so the team, joint NASA SpaceX team, has been working through all the joint operations and done the full-scale medical triage exercises too. So this is going to be a major choreography day, working through landing exercises, making sure we got the right landing conditions to be able to go do all the crew recovery and stabilization efforts, and then getting the boat back in. But the team's been practicing it. NASA team's been involved working through it, obviously working through protocols with our medical folks and their support folks and everything else, how this is really going to work, working through that.
What kind of sea states do?
It's where we're in pretty limited sea states. I mean, it's going to be a really, really nice day that we'll be shooting for landings. Yeah. So, for multiple reasons. One is it's just, this is going to be, there'll be, especially for deconditioned crew, and for right now for Demo 2, we have it as a short mission, but, for anybody that's up there for a period of time, coming down and landing in the water is going to be tough. And so really that's why they've spent a lot from their boat perspective to try to stabilize them as much as possible. But we're going to be careful about the days that we pick for landing.
Kathy, I just heard you say something. Demo 2, is there an option to make it a longer duration mission?
We are looking at, the vehicle's capable of a longer mission. And so, we're doing an assessment right now, Wayne, where we're looking at, is this a capability that we want to have? When you look at where the ISS crew it may be at the time frame, I mean, it may be something that we want to go do. So we're preparing for it. We're doing the assessment so that if it's a capability we want to use, that we're ready to be able to use it.
Kathy, can you go back to this conversation about the seafood and all that? Have you looked at what percentage of day landing opportunities you might expect to fit into the parameters?
Yeah, I mean, as you know, we've got people that's their day job and night job, and they can. So we have. I mean, we've looked at that, and then also looked at it from even understanding with the different options of launch and landing days. We've been looking at all that, and then what are the percentages of them being there during different periods of time. I think over a period of time, there's going to be, just like there is, as you guys know, kind of, it used to be that there was a period of time where the Russians won flew. There probably will be a period of time where we will want our launch and landings to be for different vehicles, understanding the constraints. Honestly, for both providers, right? Even for Boeing, we're going to have to be careful about the placarding requirements on vehicle landing, even on land, right? So I think this is going to be something that we'll be looking at for both providers. What are the right conditions for us to be able to land in? And then when are those the right, how do you kind of maneuver your 6-month missions to be able to optimize when you're going to have the best chance of being in those capabilities?
What about an unplanned departure from ISS?
Yeah, we're looking through that too, and then obviously that's part of our crew rescue where we're getting people set up, and then honestly also the capabilities of the vehicle that we have. But as you know, there's probably there's a risk assessment discussion here about if you have to come down. It's the hard trade that we've always had to make about, is the risk of staying on orbit more than the risk of potentially where you land. Obviously, we would always be targeting for areas where we could support them, and the capabilities are set up to be able to, as we come in, they always have a primary and a backup site, right, that we're aiming for. But we also have plans in place if we have a bad day, how we would deal with that.
Can't beat Mother Nature.
No.
I've studied weather for 15 years.
No, I don't, I think we'll be having lots of weather discussions. That's the, you know, to me, when you start having weather discussions, means that you're getting close to flying. So I'm happy that we're starting to have weather discussions, but I think it'll be the bane of my existence too, so.
At the end of the day, who makes that decision?
So it's gonna, you know, we have a process where it goes up, right? So we right now are putting together all of our flight rules and when we're gonna make the decision from a weather perspective. And then, you know, if people don't agree, we have a process for how we go up until, and it could go all the way to the administrator.
Oh, no, that's too far.
No, I know, but so right now, well, you know, so right now we have a process for, you know, between the NASA.
Let me rephrase the question.
You're talking more about, does the contractor make the decision or do we make the
Yes.
decision? Yeah. So we always, if we don't feel like it's a condition that we're safe to put our crew on, we don't put our crew on. So that's a joint decision.
And who
at that
decides
point.
that? You or somebody else in the system?
Well, right now, that's being done by my DMMT chair, which for the OFT mission will be Steve Stitch.
Okay.
And for, you know, future missions, we have Mike Hess who's in. But the goal is that that's your day of launch. The person there, that's the MMT, my MMT chair will be making that decision.
Okay.
That brings to mind, so the COFR, Certificate of Flight Readiness process for the first crewed mission, I guess that's been established for some time. Is that being exercised for these other activities here, preliminary to that for the first flight? You know, are you going through what I would call the COFR process so everybody knows, even in these simulations, what the responsibilities are?
Absolutely, and I think what's been nice too about the uncrewed missions is we were having our trial run. Obviously, when we're doing our agency FRs on the uncrewed mission, it's really focused on what's the crew safety aspect of its on board station, that piece of it. But we did our internal STRs with the providers, and we went into agency FR and practiced that. And not practice, but we did the agency FR, and then went to what would be the same process if it was a crewed flight, working through these pieces. Now, obviously, an uncrewed mission has a different risk posture, but the process that we went through is the same process that we go through, even for a crewed mission. And so we're working through that right now on the Boeing side, and we'll use that same process then when we get to the crewed flight test.
Okay.
But you're exactly right, Bob. I mean, 3 years ago I said we better get this figured out now and get our COFR plans figured out now. And it's still, as we were working through our getting ready for the demo one, we had to kind of let everybody know this is the agreements that were in place and the process that we're going to have. And then we went through that, and actually afterwards we did our lessons learned and said, is there anything we need to do to change it for the next time to make it more efficient? And we actually rolled those into our process that we're using for OFT and demo 2 and CFT.
Let me make sure you understand something I said about the administrator. There may be occasions when the administrator needs to get involved and nobody.
No, that's not my standard plan. Yeah, but yeah.
Routinely, a good ground rule is the ops guys make real-time decisions, not the administrator or his deputy or someone like that.
Or even the program manager.
And the program manager. And that has served us well in the past. Now, there's been a time or two that it has gone to the administrator. Deciding to do that 3-man EVA was a tough decision that got reviewed multiple times by Golden. But that's one time out of, I don't have any.
So really what we've done is work together to go establish the flight rule that governs. So first of all, you have your flight rules, but then we also said, hey, when you're heading into getting ready for the launch, which the weather pieces have, we put that into the DMMT. So that's the joint contractor, just the near real time with our joint mission management team that's making that decision. Are we heading into a launch with the weather in the 4 regions that we have up the coast? And then obviously there's day of launch. If something happens, then we got folks on console, we're training for this, they do sims with this, with the flight rules and everything else to make sure that they're trained to be able to make those decisions in that real time, near real time aspect. So this is we're getting into flights, this is the tough thing, and the sims, honestly, as we were getting ready for demo 1 was a great. I don't think we would have thrown as many things as we did at it. It was a great sim for us for food flight with all the things we had to go work through, and we were able to afterwards say, yes, that part was okay for an uncrewed mission. This is what we would have done for crewed missions, and working through that.
Who does the simulation timeline, objectives, and cases, and so on? Who's the sims who?
So they're each of the contractors has their simulator person, but then we have an integrated flight director. So we have an ISIS flight director for the integrated sims that works with their counterpart, and then for the standalones, the contractor themselves set up what they want for their sims, and then we support them. But we have FOD folks are working. Yes, we have standalone, and then we have ones with the space station, and we have flight directors that support both the standalone and the joint sims. So we have ISIS flight directors, obviously, that work. FOD guys are working with making sure that they're working through the joint sims pieces. But the point here is that we're wanting Boeing and SpaceX to be figuring out how to do this, and then we're working with them on how does that really work with our insight. It's a very tough situation.
I used to say there was 29 failures in every ascent sim I did.
Yeah. Yeah. So if you would have asked me 5 years ago, how's this going to work? How the teams work together would have been one of the toughest problems, I thought, and how you work. Because you got to make really clear whose responsibility is it. We spend a lot of time on because you don't want to be there in those real-time cases and not making it clear who's responsible for the call at that point, because that's where things get messed up, right?
But having the best people you can find to build sim cases is very important.
Right. What's been good is on the SpaceX side, with their flight experience and thinking about it, and then having the NASA team that's trained and has been working with them, that's been very helpful. It's also very helpful on the Boeing side. We have Leroy and Richard Jones, who's the experienced NASA flight director that is working with the Boeing, and really the NASA team's working as the Boeing flight ops team. So I think having that kind of experience on both sides has been a real blessing for us.
Kathy, is going to be anything like a TCDT?
Yeah, we've actually going through those right now. So making sure that all the like right now, Fergie had the whole team there doing checkouts on the vehicle, on the spacecraft vehicle, working through all those pieces. So really, I think the processes that we've had in place to do checkouts on it have been implemented by both providers.
I was specifically asking about, TCDT, the launch team is in place,
Yeah.
The whole countdown,
Yeah.
They're going to do something like that.
That's what I meant for the dry run, for the different pieces. When we get ready for the static fire, that's what we talked about. That's what they've been doing. Go do the whole walk down, go in, get in the vehicle, make sure the timing there, do the joint figuring out, making sure our timing on the different pieces there. We've done big thing we had to go figure out is, are our timelines, what we're nervous about is you have these established launch vehicles, and now you're holding for longer, really, for both of them. And you want to make sure that you're really understanding that you've got the timeline down, so you're not inherently putting risk potentially on the launch vehicle with your timeline, and make sure that we've got that piece nailed down. So both the Boeing and the SpaceX teams have been working through and doing dry runs on how they're doing the crew loading piece, and then practicing also on the spacecraft on the ground. But it's something we're really worried about, and wanting to make sure that we've, and honestly having experienced crew like Sonny and Bob and Doug, and working through that, and kind of working through the different lockdowns of the providers, and making sure that there's enough margin kind of in the schedule to be able to do things has been really important. But wet dress is going to be a big deal. Wet dress coming up on the Boeing side, the Boeing ULA side is a big deal for us. Working through IDOLT, which is kind of what their TCT, making sure that they've got all the crew pieces nailed down. Us getting in and doing the checkouts on the in-flight abort test in December is another big thing. So people are wanting to make sure that we've got those kind of what we're viewing, those are kind of critical practice sessions in there for us is important.
You want to make sure we have enough time for you to say all of it. We've got a bunch of ops people, and we're just ex-ops people love to talk about this stuff, but we want to make sure you get through your presentation here. So.
I think I got a few. This is the big chunk. So the next slide is, so we've had to figure a lot of things out. I think the last time, we keep using the same slide, but we had to put the plans in place, but now it's really where we've had to go figure out how do we really make this work together, how this interagency piece really work together. And so, we're in the process now of how we're working through transition on the NASA missions, which are the demo missions, into the license phases, and making sure all of our insurance regimes, how we're working through all of our probability assessments, working through, air traffic control, all these things. It's not easy. but we've learned a lot. I think, thank goodness for the, our interfaces and the folks we have, and the folks that have been working with us from an FAA perspective, working through these has been critical. The DoD relationships we've had to have with making sure we've got the debt recovery we need, we got the support, working through SARSAT agreements, we're all the range agreements that we've had to work. If you can imagine, we've had to get, environmental assessments on 4 ranges, working through the different agreements to make sure priority is always an issue, and working through that. Sometimes you have agreements on what are tools for the range and flight termination systems that in some ways don't necessarily agree with crewed flights, and so we've had to work through kind of working collaboration and making sure that both our range and our crewed, and you and Tom here are well aware of how this all that
it's very complicated,
right?
Yeah.
And then working through making sure that these are going to be FCC licensed, because as we're moving into post-certification missions, they're FAA licensed missions, so we're working, making sure we have the spectrum priority on the bands that we need to be able to have crew comm for our missions, and making sure we have the right priority there. So, and then working with the NTSB on really how we don't ever want there to be a mishap, but we want to make sure that we've got our mishap plans and agreements and planning in place to be able to support those. So sometimes the easy part is getting the hardware together. So this has been a tremendous amount of work.
Want you to be aware that after our last meeting, and you described some of this, our committee put a recommendation forward to the agency that you guys are an example of interagency cooperation, and the rest of the NASA could learn from your experience. So, we attaboy. So,
Yeah. I'll take it. It's taken a lot of work in coordination with a lot of folks, so we obviously have had a lot of help along the way. So we don't, we tend to focus a lot on the crewed missions, but I don't want us to forget about the work that we're doing with Blue Origin and Sierra. So next few slides, just talk about, because I still feel like these are valuable interchanges for us. We're actually getting ready to have another, one of our biannual meetings, and coming up in early November with Blue folks. There's a lot of discussion going on, a lot of work going on doing interchange of data on parachutes and structures and different mission operations, and working through. We've had a ton of launch vehicle technical teams. Still, the Blue folks are still asking for a ton of data from us. So really feel like this is been valuable, and honestly, it's been fun for our team. It's just a lot of, I love the fact that when you work on commercial crew, you get to work on all these different space system designs, and so it really gives folks a chance to kind of, once again, try to deal with their particular technical issues and looking at things in a different way. So we have a KSC structures, Tim, and so we're really in the process of as they are wanting specific technical interchange, we're working with them. And Sierra, they're continuing, obviously their primary activity right now is working through supporting CRS-2 and the station program there. But they continue to want us to support any questions that they have, because they're really kind of viewing, at some point, being able to fly crew with this vehicle and making sure we have an interface and are following along and continue to work with them on any questions they have from a crew interface. But really tremendous. It's a lot of this progress, I think, is really CRS-2 progress, but we're still working with John and the folks as we've been making progress on their vehicle. So Wayne, this is what I had for you guys today. Next slide.
Well, thank you. Okay, for the committee, do you have any questions on the commercial crew program? Obviously, it's been focused on the near term.
Yeah.
After you get through, this may be hard for you to say, but after you get through the first few flights, what's the long-term outlook for your office? What do you see your office doing, sustaining, or whatever you call it?
So, we are focused on getting to the point where we're providing consistent, safe, reliable services to the space station. And I'm not fooling myself that, and people kind of say, oh, you flew your first mission, no problems, right? I think we'll have some work getting to where we are doing these vehicle flows consistently, and it's going to take us some work to be able to go do that, right? So we're really working right now, Wayne, on getting to where this is, people aren't worried about when we're going to fly, but I think it's going to be a little bit of time. And honestly, as you know, 6 missions isn't that easy, and it's tough to get through 6 missions. 6 missions doesn't mean it's all a piece of cake either, right? So the goal is we are trying to get through the development effort, and then our goal still is, I think we've been a good example of a fairly small program structure to be able to go conduct this effort, and our goal is moving forward to get to a small program structure to do sustaining efforts and delivering services. I think that's a good, kind of I want us to get into operations and show we can do that, because if we can do that successfully, then maybe we can be a model for other human spaceflight programs that are out there. But we've got to show we can do it successfully. We're not there yet. You know, I tell everybody we've only done one mission. We got to get through these abort tests next week. We've got to get into our finishing up our demonstration missions. And we've got a lot of work to get to consistent services for Kirk. So we can't lose. We can't keep our eye off of that. You know, right now we got to make sure we're doing this right.
It sounds like you're not gonna, how the cargo program was absorbed into the land or whatever it is.
Yeah.
Is that not gonna happen, or is that still TBD?
Well, right now our baseline is that we have established program capability through 2024 from a PPP standpoint. So the goal, I think, Gerst made a decision 2 years ago, hey, this is different from a risk posture perspective. It's different. How you sustain it, it's different. So that was when really the crew line item from phased out, right? So obviously funding still in for the missions is still in the crew cargo line item as a group, and we're working that with station book, but the baseline FTE support, almost kind of like the LSP model, the people are all there, and then we work with Kirk on what do we need to fund the contract from a KSC standpoint.
I know your relationship with Blue Origin and Sierra Nevada is different than with Boeing and SpaceX, but what will it take for them to achieve a certified crewed capability, and when do you think that might happen?
Oh, I think you have to ask them, right? I mean, I think right now we're just trying to help with anything that they need to be able to start laying out their planning for that, but Pat, I can't tell you.
Will it be, essentially a private investment kind of situation that ultimately gets them there, assuming that they do?
You know what's great about these situations is it's up to them, right? And so what we're here for is if there's anything from a knowledge-based perspective that NASA has. I mean, we're an investment for the nation, right? So if there's anything there that we can help them with to be able to get them, that's definitely in our mandate from a program standpoint to help them get there. I think Blue's got to talk about what their plans are, and Sierra's got to talk about what their plans are. I don't want to talk about it.
Now, if for some crazy reason you needed the Dream Chaser to start flying crews, your answer would change.
So we have a capability on our contract to on-ramp people. So if we all plagiarize off of each other. Amanda's got a great clause in her NLS 2 where she can on-ramp, and we have that same kind of clause that if for some reason we had one of the providers that either didn't want to provide services anymore or want to do it, we have the capability to be able to on-ramp more capability. So we could do something, again, that said we went out and said, is there anybody else that would want to offer that capability? And then we'd work a certification, just like we're working certification now, to be able to get that. And they obviously have a requirement set to be able to look at, and if it's something that they want to work on, themselves, they have all the requirements that's out there are available for folks to be able to work on.
Kathy, these remaining uncrewed flight tests will obviously close out a lot of open certifications that are still out there. Can you give us a feel for, is there a bow wave of that stuff like parachutes, or is it a manageable amount of work? A lot of people look recalling previous first attempts to fly crews and missions. you get near the end and it looks like all the work is done, and they say, oh yeah, but there are 3,000 and some open certifications remaining, and we got this offline analysis or offline testing or whatever that's still got to be done, and on and on.
So I think, so for Boeing, I mean, the fact that, they've gone through structural testing and environmental testing, and obviously there's still a certain amount of paper or analysis deliveries for CFT that still has to come in, but our certification work for OFT is in, and the team's plowing through it right now, right? And so we're having all of our readiness reviews back down the hall. Our engineering folks and Ralph are all meeting on their final OFT FDR assessments across the board. So we're really burning down. We're at burn down phase. Right? Getting through validation tests like the paddleboard test is going to be a big deal for us, right? For the OFT mission, like I talked about at the beginning, if there's an issue with a launch aboard engine or whatever next week, that won't necessarily hold up the OFT mission, because that mission does not have the engines on them. But you know, we go do a test and you go look at the data and you say, is there anything in that data that is making us worry about something we got to worry about for the next mission? So, but I think we have burn down plans on everything. I mean, it's
So there's not a mountain of paperwork out there.
There's always a mountain of paperwork. I mean, see, if I had my structured guys in here, yeah, there's paperwork.
There's paperwork,
There's
but then there's real,
and then there's real paperwork, right?
real paperwork.
There's a mountain, yeah.
Like parachutes.
So,
Yeah, I think right now, you know, obviously getting through the abort test is a big deal. And, we need to see that. But for the rest of it, we're working. I think we're working through it.
so I hate to stop this conversation, but we're over time here. I know Kathy has other real work to do. We have other people to hear from, but thank you very much, and best of luck.
We're hoping I had 98, but I'll be